The Tevarin. While Star Citizen's lore is replete with information, not much is known about the visual language that characterizes them. How does their culture influence their craft? What can we learn about their civilization from the way they build their spaceships? That's where the currently in progress Prowler armored personnel carrier comes into play, where, much like the Banu Defender before it, it aims to define the aesthetic of our now assimilated antecedent alien avian adversaries.
All right, so we're taking a look at the Prowler's white box. So you'll notice that we have the landing gear here split out, the rear landing gear. We've got a section here for the pilot and co-pilot, which sits right below him. And then we've got chunks of the interior boxed out and separated out to the side. So this is essentially a block out for us to plan the work that we have to do. This gives us an idea of where the major problem parts are for us to focus on as we actually develop the vehicle into gray box and then further down the final. I can show you where I'm at with the interior. So on the interior, we've got the cockpit, we've got the co-pilot cockpit. We've also got what we're kind of calling the component room. And so we'll have pretty easy access for players to be able to just walk up, press a button, boop, the whole wall opens up, and then you have access to all of your components. And just to kind of give you a sense of how this looks in relation to the pilot enter-exit, you've got this nice big hatch that pops open, creating a seal, and then you've got the pilot seat which turns around. Something that's kind of interesting about the ship, which we're attempting to do, is we really kind of want to give the cockpits a very different feel, especially for the alien spaceship. So we want all of the ship movements to be controlled by a single input. This system here can essentially move in every single direction and rotation. So when it's all set up, the player will be able to sort of rotate the joystick to the right or to the left, and the entire stack will rotate. So you'll actually see a cascading set of animations all the way to the front of the dashboard, giving you a bit of an offset. So it'll be really freaky and totally different than any other cockpit we have. So I think that's gonna be really exciting. This is the first time we've kind of shown what the Tevarin interior style is. So you might be wondering what's going on here, but they're inspired by birds as a species. We're gonna have shapes inside of spanned the higher up they go. So you'll notice you have this kind of like upside down triangular shape. And you'll also notice that a lot of the big supports here, as they travel upward, branch out more and more, right? Sort of giving you that feel of both trees, and also when you look up and when you're inside of that space, the noise that surrounds you is supposed to kind of feel a bit like a nest. So you've got this crazy mechanism in here, similar to the cockpit section, which kind of swallows up the ladder as it comes in. Everything kind of folds up neatly, closes up, gives you a nice little seal. And then you can have 4 guys ready for battle here. What do we have left to do? So if I look at the ship here, let me turn off the lights and I'm gonna reveal some of the sections. So this is the rest of the interior. In terms of the interior geometry, that still has to be built. So that includes mounting all of these jump seats to the ceiling, building out and designing the interior, making sure that the rear hatch is working properly and seals properly with the exterior. And then we've got all 8 of these sort of jump doors that also have to be set up properly and sealed with the exterior. Then once we marry that with the actual exterior work, which you can see here on this hatch, then we'll have all of the geometry finished and ready to go. Beyond that, what we'll have to do is create an entire material set, which is unique to the Tevarin, and then we'll have to go through our final pass, which is a long process of adding palms and decals and materials and textures to everything to make it as beautiful as possible, as well as actually getting the lighting done in engine. Right now, this is sort of my Maya preview of the kind of lighting that I want to do. This is just like a lighting block out. So quite a bit more work that still has to get done on this thing before it is ready for flight, but I think it's looking pretty cool. I hope you guys enjoyed it.
Whether it's building ships, designing game systems, programming features, or more, the tools we use to build Star Citizen are an essential part of any game's development. That's why this week we're excited to shine a light on those folks who build the tools for our developers here, who then turn around and use those tools to build the features for Star Citizens out there. Let's take a look.
As a games developer at Cloud Imperium, we use a very large number of tools. Some of those are developed by engineers within each individual team. So we develop primarily two sides. One is we look after the engine, the editor, which is sort of all of the in-engine tool side of things, and that helps the designers and bring together all the great content and create all the fantastic locations we see around the universe. We then also have what we call general tools, which are more for general business process and managing workflows, and they can be everything from automated testing through to grabbing builds, reporting crashes. So for some more specific examples, two tools that you may be familiar with because they've been seen on around the verse previously is copy build, which is used by pretty much every developer every day to pull builds from the build system that is housed in Austin. So another tool we've also seen on around the verse is Data Forge, which is quite difficult to explain. Within the game, almost everything you see has lots of configuration data. So one of the great benefits of Data Forge, it allows us to have master records and then variant records. And this means we save a lot of time updating records and configuring these items that appear in the game. So one of the tools we've been recently developing over the last quarter, and we're hoping to release it for general use this quarter, is a new tool called StarWords. And StarWords is there to help us manage all the text that's in the game. We did have another third-party solution we were using, but it was web-based, and that caused a lot of trouble in terms of getting it into the build, managing to get use Perforce, which is our source control management system, to do versioning. So because it's a desktop application, not only can we provide a much richer UI, which makes it a lot easier for the users to actually get the content in, search the content, and organize it all, it also means that in the future we'll be able to link it into the editor, so we can make changes to the text and see it directly in-game, either in the editor or in the client, as that text is being entered, which obviously will have quite an impact in terms of layout and styling of the text that you will see. So one of the other things that the tools team handle and look after is automated testing. So we probably produce something like 20 builds every day, and each one of those goes through a suite of tests to ensure that we get build stability and we don't see issues reoccur. This has been particularly important with the Vulkan work we're doing at the moment, because obviously that's creating quite a large change across the graphics subsystems, and we want to make sure that what we deliver through Vulkan is absolutely the same as we've done with our current solutions. One of the major people who put a lot of work into it is Matt Jones, our graphics embedded QA.
As you can imagine, we hit quite a few problems trying to test the game, especially with the magnitude of a title like ours. We've got a massive universe. We can't run around, to each corner of the universe. It's just impossible. So what we do is we've got a tool called the Graphics Viewer tool, and what it does is it runs two images side by side and creates a heat map, which we can then detect differences between the two images, and it's done by pixel differences. So as you can see, we've got the first map, second one, third one. We can automatically see the differences between those images. Now how we get these is we actually run a sequence within the likes of a test level or within the megamap itself. So if I just show you a quick preview of the level, you can see we've got a lot of tests around different hallways, different areas to look at. It really brings into perspective just how much different tech we've got, and to be able to obviously break down each portion of the tech rather than having to look at it within the megamap. It'd be easier to just have everything broken down significantly and then figure out where the issues actually lie. So from there, we'll run a capture through a CVAR. As you can see, it goes pretty swiftly. So we can get about 180 tests done in about 2 or 3 minutes, which is obviously going to save a lot of time in the long run for testing. So once this is done, so if we go back, so we've got 2 different modes in fact. So we've got a regression mode and comparison mode. Comparison mode is where this is most handy. So this is where the team might say they've got a clean build. They'll run one of those quick tests where they'll get all the captures, then they implement their code changes, then run it again. And this is where we can obviously look at the different captures and see where the changes are going to actually really hit. So as we go through, we get the first image, and then we get the second image. We can see the slight differences already, and then the heat map will automatically display this. This works again, in a comparison mode where, as each build is made incrementally, we can actually then look at the build changes that are happening every single build that we're expecting to be a clean build, and just make sure there's no issues basically happening. As you can imagine, you know, automation doesn't pick up everything. There is a bit of manual labor that obviously still has to be put in, but this still saves a lot of time. The way that the tool works, you know, it really helps to identify those problems as we go along, rather than relying on hours and hours of manware to try and discover these issues. You know, we can do it within the space of a few minutes.
So that's a brief look at what the tools team has been up to recently and some of the future plans. But we're very excited to maybe hopefully show you a lot more about what we do in the future.
So what did we learn this week? We learned that a ship is more than just a ship when it's the touchstone for an entire species' visual development. That the tools that make video games possible are as essential a part of Star Citizen's development as anything else. And that CitizenCon is 1 week away, and as such, this will be the last ISC between now and then. But don't worry, you can tune in on November 23rd at about noon UK time for the pre-show and an entire day's worth of Star Citizen development updates. So for Inside Star Citizen, I'm Jared Huckabee, and I'll see you at CitizenCon.
Thanks for watching. For the latest and greatest in Star Citizen and Squadron 42, you can subscribe to our channel, or you can check out some of the other shows, and you can also head to our website at www.robertspaceindustries.com. Thank you very much for watching.